Welcome, Algebra students at Midwood High School. This is Mrs. Lobo. Today we're going to be talking about identifying transformations of the parent function of the absolute value of x. So, absolute value. So y is equal to the absolute value of x. This assignment is due on the 11th, so you should be doing this on the, this assignment is due on the 12th, so you should be doing it on Tuesday the 11th. And let's take a look at how we can transform an absolute value function. So you'll see that we have the graph of f of x equals g of x. So let's go ahead and label our graph. F of x is equal to the absolute value of x. So now we're going to think about adding and subtracting values from that x value to see how it changes the graph. This is going to be called a shift or a translation from your work in middle school. So if I have the graph where I add 4 to the absolute value, so x plus 4 inside the absolute value, we want to graph this. So let's take a look and see what this graph looks like. So I'm going to go to y equals, I'm going to clear out whatever's there, and I'm going to say math, tap math, I'm going to scroll over to num, and I'm going to hit option 1 for absolute value. Then I'm going to type in my variable button to get my x, and I'm going to add 4. I can tap out of that to get outside of the bars, and then you might want to look at the graph, see what that looks like. So we can clearly see that there's some sort of shift to the left. Well, let's look at the table so we can see if we can identify the vertex or the turning point of our absolute value function. So what I'm seeing in my table right now is my y values are increasing as my x values increase. So I'm going to scroll back or up to more negative values until I find some symmetry. So here you can see that there's symmetry around the point -4, 0. I have 1 above, 1 below, 2 above, 2 below, etc. So there's symmetry around that point, so that is our vertex. -4, 0. You'll also notice that the y value is the smallest y value in the table. After 0, if I go more negative in the x, my y values are larger. If I go more positive in the x, my y values are still larger. So this is the lowest y value, or the smallest y value. So this is called our minimum. This is our minimum. Okay, so let's hang on to our vertex -4, 0. And I'm going to do a quick table. And I'm going to place my vertex, -4, 0, halfway down my table. And then I'm going to pick more values that are more negative than -4. And I'm going to pick values that are larger than -4. And I'm going to fill in my y values from my table. So now I can graph. So I'm going to start at -4, 0, and I'm going to plot my points. And you'll notice there's some symmetry happening here. Now I can continue to plot points, but I can also grab my straight edge and I can graph my absolute value function using 2 straight lines that pass through the points that I plotted and extend through the entire coordinate plane that we've provided you. So we have to answer the question, how does the graph shift? So if I add 4 to the graph, what happens to my absolute value function in comparison to f of x equals the absolute value of x? So when adding, to x, the graph shifts in what direction? It shifts to the left. So if I add 4 units to x, I shift to the left 4 units. If I added 2 units, I would shift 2 units to the left. Okay, on the same axes, we're going to graph f of x minus 3. So we're going to take 3 away from x. So I'm going to look at my graphing calculator. I'm going to go back to y equals, and I'm just going to clear this so I can practice entering an absolute value. So I'm going to hit math, I'm going to go over to num, hit option 1 for absolute value, and now I'm going to type in x minus 3. I can peek at the graph, and I notice that my shift is now to the right. Let's look at the table. So I'm looking for, clearly I have a minimum value, so I'm looking for the smallest y value in my table. So if you notice, I'm decreasing 12, 11, 10. So I'm going to see if I can find the smallest y value in this table. And I see it. I have the smallest y value at 0. So my vertex is 3, 0. Again, this is the smallest y value. So that means that this is, again, a minimum vertex. So we're going to hang on to our vertex. I'm going to do a quick table, 3, 0, and I'm going to record values smaller than 3 and values greater than 3 and record the corresponding y values. I'm going to pick a different color, and I'm going to plot points for f of x minus 3. So I'm going to start at my vertex, and I'll plot my remaining points. Again, I'm going to grab my straight edge. And I'm going to use my straight edge to graph my absolute value of x minus 3. And I extend that through my graph. So I didn't do this before, but let's label our graphs. So the blue function is f of x minus 3, and the red function is f of x plus 4. Let's make sure those are labeled. That was in our directions. So now we need to discuss how this graph shifts, given that we subtract 3 from x. So we can say, when subtracting from x, the graph shifts to the left. Beyonce has a whole song about this. Okay, So now let's go to part 2. So let's think about adding and subtracting a constant from f of x equals the absolute value of x. So we're not subtracting or adding to x or from x. We're now adding or subtracting from the entire function. So you'll notice that we're not inside the absolute value sign anymore. We're now on the outside of the absolute value sign. Okay, well, let's enter our first equation into our calculator where we're adding outside of the absolute value. So I'm going to clear my y equals. I'm going to hit math, go over to num, option 1 for my absolute value. I'm going to type my x in, and then I'm going to hit my right cursor to get outside. And I'm going to add 2. We're going to look at the graph. And you'll notice that the graph shifts up. So let's look at the table. And we're looking for the smallest y value in the table because, again, we have a minimum. This is the lowest point. So since we have a minimum, we're looking for the minimum value in the table. So if you notice in our table, our y values are increasing as our x values increase. So let's go back and see if we can find the smallest y value. So I have 7, 6, 5, I'm starting from the bottom, 4, 3, 2, and then I start to increase again. So my minimum value on my vertex is at 0, 2. Well, let's draw a quick table. My vertex I'm going to put in the center of the table. I'm going to make points smaller than y and larger, or excuse me, points smaller than 0 for x and then larger than x. And then I'm going to begin filling in my y values. And I apologize, but this should be over here. Okay, so now let's plot our points. So I'm going to pick a new color, so green, and I'm going to go to the point 0, 2, plot a point, plot my remaining points, and use my straight edge to graph my absolute value of x plus 2. And let's label it. F of x, close parentheses, plus 2. So how does this graph shift? The graph shifts, so when adding to f of x, the graph shifts up. Let's make a prediction. What do you think will happen when I subtract 5 from f of x? Let's take a look. Go back to y equals. I'm going to hit clear, math, over to num, option 1, and I put my x, and I want to subtract 5. So let's take a look at the graph. I would bet that you made a prediction that the graph would shift down, which it absolutely does. So we're going to talk about another way to determine our maximum or minimum value. So if I have an absolute value function, we have to decide if it's an absolute max or an absolute min. If the absolute value function has a maximum vertex or a minimum vertex. In this case, the vertex is the lowest point, so that is a minimum. So I'm going to hit the second button, calc, and I have some options here. I'm going to select option 3, minimum. So we're going to hit option 3. And then it has this question in the bottom left corner of your screen. It says left bound, question mark. That means that I want this little blinking cursor to be on the left side of my vertex. I'm going to hit enter. Now it says right bound, so I'm going to move my cursor. I'm just tapping my cursor over to the right side. And I'm going to hit enter. And then I'm going to hit enter one more time so my calculator will make a guess. Okay, so now I have two numbers. This x value is really 2.0, let's round it to the nearest hundredth, 7. The e stands for times 10, and then it's raised to the -6th power. The e is the exponent. This is an extremely small number. This is the number one, two, three, four, five, 6. 0.0000207. This is extremely small. This is very, 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 very close to x equals 0. Now, if you look at the y value, that rounds to what whole number? Y is equal to -5. So our vertex is the point 0, -5. So I'm going to hang on to that. And then I can look at my table to build my other points. So I'm going to hit second table, and I'm going to find the value x equals -5, y equals 0, and I'm going to center my table around that vertex. So I will record my table on my paper. So I have my x and y, 0, -5, and then I'm going to record my smaller x values, my larger x values, and record directly from my calculator. So now I can plot my graph. So I have 0, -5, and I plot my remaining points. I'm going a little crazy here. However, I can use my straight edge to make sure I'm drawing a perfectly straight line. And if you're super, super neat, you will realize that all of your absolute value lines are parallel. I have my blue line on the left is slightly off. I must have tapped that, and it didn't line up perfectly. So let's label our graph. I have f of x -5. How does the graph shift? Well, when subtracting from f of x, the graph shifts down. Okay, let's turn the page. Well, now let's look at wide and narrow functions. So again, we have our original parent function, f of x equals the absolute value of x. And we're going to think about multiplying f of x by a number, a. How will this affect the graph? Make a prediction. So let's enter this into our calculator. We're going to clear, and I'm going to look at A, where I am going to multiply my function by 2. So I'm going to say 2 math, num, option 1 for absolute value, x. And then let's take a look at the graph. Well, my vertex is at the origin 0, 0. So let's check out our table. Here's my vertex 0, 0. And then I have numbers above and below that are greater than 0, 0. So this is, again, a minimum vertex. So let's record our table on our paper. So x, y. My origin is 0, 0. I'm going to plot a couple, values for x that are below and above, and my corresponding y values. And I'm going to choose blue to graph the function g of x is equal to 2 absolute value of x. So I'm going to start at 0, 0, and then I'm going to go to negative 1, 2, and 1, 2, negative 2, 4, and positive 2, 4. I'm going to grab my straight edge. And graph my absolute value, extending my lines through the entire graph. Make sure you have your arrows on the ends. And I'm going to label my graph. So this is g of x, oops, excuse me. This is g of x. And that equals to absolute value of x. So how does the graph change? Well, compared to the original parent function, when multiplying, by a number, and this is going to be greater than 1, so A is greater than 1, the graph gets narrow. The graph narrows. Let's look at B. Well, now I'm multiplying by a fraction smaller than 1. Let's look at our graphing calculator. I'm going to multiply by 1/3. So go back to y, clear it out. I'm now going to use my alpha y equals. I'm going to choose option 1, and I'm going to type in my 1/3. I'm going to hit math. Math over to num. Oh, math. Over to num. Enter x. And let's look at the graph. Wow, this is much wider. Origin again is a minimum, or excuse me, the vertex again is at the origin and it's a minimum. Let's look at the table. So now I know that my origin is 0, 0 is my vertex. So I'm going to center my table on that value. And then I'm going to look for points that are whole numbers. So, for example, -1 1/3 is not a whole number or an integer, so I'm going to skip that one. But I'm going to pay close attention to -3, 1 and 3, 1. And you can continue to 6, 2, and guess what? If I go back up, -6, 2. So let's record this on our paper. So my origin is 0, 0 is my vertex. And then -3, 1 and -6, 2 are my other points. And then it was +3, 1 and 6, 2. Okay, I'm going to pick a new color. I'm going to go with green. I'm going to plot my points. Start at 0, 0. From overlapping with my vertex of my blue and my original parent function. And then -3, 1, and 3, 1, and 6, 2, and, excuse me, -6, 2, and +6, 2. I'm going to grab my straight edge. And I'm going to draw a straight line through my points and extend across the entire coordinate plane. Now I need to label. This is h of x is equal to 1/3 absolute value of x. So how does the graph change? Well, when multiplying by a number such that a is between 0 and 1, how does the graph change? The graph widens. Okay, finally, we need to graph m of x is equal to negative absolute value of x. Let's go to our calculator. Y equals, clear. And we're going to use the negative button at the bottom right corner next to the enter button. And then we're going to create our absolute value bars, math num, option 1, x. Make a prediction. What's going to happen to the parent function if I multiply by a -1? Let's check the graph. Oh, interesting. Instead of a minimum, we now have a maximum vertex. So when we multiply by a negative number, we reflect over the x-axis, and we now have a maximum vertex or turning point. So I know that the origin is our vertex still, so let's look at the table. And I have the vertex here at the origin, and then I have the points above and below that I'm going to record on my paper. So I have 0, 0, -1, -2, 1, and 2. And now, instead of like my previous, I'm now getting more negative instead of more positive. So let's graph. So I start at the origin, and I'm going to plot my remaining points. And then I grab my straight edge. You're probably bored of me by now. And I'm going to draw a straight line and extend it through the coordinate plane. And then I'm going to label my graph. M of x is equal to negative absolute value of x. So how does the graph change? Well, when multiplying by a negative, number, the graph reflects over the x-axis. So we should also make a note that thinking about an egg, if I multiply by a negative, but that negative is -2, -3, values that are more negative than 1, my graph will narrow and flip. So let's go back and revise our change when we're multiplying by a number greater than 1. So we're going to go back here, and we're going to say, well, that number can be both negative or positive as long as it's greater than 1 or less than -1, my graph will narrow. So we can represent this situation by putting our A in absolute value bars. The same thing is true for when we're multiplying by a number between 0 and 1. If that number is -1/3 or -1/2, my graph is still going to widen, but it's also going to flip, which means that the absolute value of A has to be between 0 and 1 for the graph to widen. Okay? Let's look at part D. So when matching, or excuse me, given that we know f of x is equal to the absolute value of x, let's match their graph to their equivalent function. So my first graph has a vertex at -1, 2. So looking at the options for the functions, I know that if I subtract 1, I shift to the right. And if I add 2 to the outside of the function, I'm going to shift up. But we have to consider that this is I'm thinking about the value that I'm putting inside the absolute value bars with the variable x. I have to consider that that number is being subtracted. So really, what we're looking at here is a absolute value of x minus a minus 1 plus, okay. So I know that I'm going to shift up for plus 2. And then I'm subtracting 1, which is going to be this one here. So I'm going to put an A here. Here, graph B, I'm shifting to the right 2. Well, if I shift to the right 2, that means I'm subtracting 2. So I have x minus 2 inside the absolute value bars. So that is going to be the first option. Graph C is a reflection, and it's a shift. So really, I have where I'm shifting to the right, so it's going to be x minus 1 inside the parentheses. I'm shifting my vertex up 3, so I'm going to add 3. But I'm also making it negative. So I have to change my function to reflect that as well. So this is graph C. Considering what you know about transformations on f of x is equal to the absolute value of x, Sam predicts that the function s of x equals negative 2, absolute value of x plus 3 minus 1. We'll have a vertex at 3, 1, and compared to the parent function, the graph will be reflected over the x-axis and be narrow. Is Sam correct? Explain your reasoning. Well, if I'm adding 3 to x, I know my graph shifts to the left 3 units. If I'm subtracting 1 from the parent function, I know my graph is going to shift down 1 unit. So my vertex actually is at negative 3, negative 1. Will my graph reflect over the x-axis? Yes, because I have a negative sign here. And then the absolute value of negative 2 is 2, and 2 is greater than 1, so that means that my graph will narrow. Well, so we can say that Sam was correct for 2 parts. That the graph will reflect and be more narrow. However, the vertex is at -3, -1. And this is also a maximum vertex. Let's take a look at our graphing calculator to see that we are correct. I'm going to go to y equals. I'm going to clear this. I'm going to say -2, absolute value of x plus 3 minus 1. Let's look at the graph. So, my vertex is clearly at -3, -1. My graph does flip over the x-axis. And let's see how much more narrow it is than my original function. For my y, I'm going to go back to y equals, and I'm going to go to y2, and I'm going to just enter my original parent function here, so we can see how much more narrow it is, if at all. Well, clearly, the blue graph, Sam's function, is much more narrow than the parent function. Thanks for watching. Have a great night.